Alright, we have a Statkey tutorial here to show you what you can do with one quantitative variable in Statkey. The first place we're going to go is under Descriptive Statistics and Graphs, one quantitative variable, and we are going to upload the data set traffic flow timed. Actually not upload, but select it from the list of preloaded data sets. So coming over to Statkey, first of all, one quantitative variable is where I want to go. And here on the drop-down box where it says mammal longevity, I can scroll down to traffic flow timed to bring up the data set we're going to work with. This data set represents wait times at a traffic signal based on a simulation where the traffic signal is timed. That is, it isn't affected by cars approaching the intersection. We first see that there are three very high outliers over here. And by hovering the mouse arrow over them, we can see what the values are. You can hover the mouse arrow over any of these dots and see what values are behind them. In this case, it looks like 138, 138, and 141 are my three outliers. So that's what I'm going to write down here under the outliers. I do write 138 down twice because it refers to two separate observations. Even though it's the same number, we want to make it clear there are three outliers, and these are the values. Now this is a dot plot, which is very similar to a histogram, but instead of bar height, we have a number of dots. So each dot represents one data value. If I come over to the histogram tab on this same display, then I see a histogram with bar heights. Here are my three outliers over here in the bar to the right. And for the shape of the distribution, I might just focus on the fact that over here where the mass of the distribution is, it is mostly symmetric. I have a really tall spike here close to 100, but this is mostly symmetric and we have three high outliers. We could describe this as having right skew, but if we acknowledge the outliers, we can also describe the distribution as being symmetric aside from the outliers. I can also get my mean and median from Statkey. In this same window over here under Summary Statistics, note that one of these is a mean, and down a few more levels I see median. So I have a mean of 105, a median of 101. We should not assume that we're expected to calculate these values by hand unless that's explicitly stated. Most of the time we're going to use software to find pretty much all of our summary statistics. So a mean of 105 and a median of 101. Now we're going to play around with the bucket slider. What I would refer to as the number of bins, they refer to as the number of buckets in Statkey. So coming back to our graph, I can see that if I pull this slider to the right, I get more buckets and more detail. If I pull it to the left, I get fewer buckets and less detail. And somewhere around 3 or 4 is where it's hard to tell that those are outliers anymore. So that's what happens when we start to lose some of this detail, is we really can't see those characteristics anymore. So right around 3 or 4 bins is where we lose enough detail that we can no longer even detect our outliers. So let's go ahead and edit that data to remove the outliers and see what our data set looks like without them. To do that, we want to click on the button that says Edit Data and then just select the outliers and delete them using the Delete key on the keyboard. So coming here, I can see at the top a button, a blue button that says Edit Data, and I can find those three outliers, 138, 138, and 141 in this list pretty quickly, hitting the Delete key and then maybe one more time to take care of that space. Then I hit OK. I'm back to the dot plot of this distribution. Coming over to the histogram here, I can see that it looks like the shape is now calling a little bit more attention to the space in between here. Maybe I would be inclined to say that either these are outliers beside a right skewed distribution, or I might just call this whole thing bimodal since the space is now more than one bar. In any case, I see that my mean has changed to 100.143 and my median is at 101, so I'm going to write those two values down. Mean is 100.1. Those other decimal places aren't so important. And the median is 101. Comparing those to what we had a mean of 105 and a median of 101. In this particular case, the median didn't change at all when we removed the outliers. We consider the median to be resistant to outliers because it usually doesn't change very much. We call it resistant to outliers. It usually doesn't change very much when we take out the outliers. In this case, the reason it didn't change at all is because of that really tall spike that we have right around 100. We probably have the data value 101 repeated enough times that even if the median shifts around a little bit, the value will just fall on another instance of 101. But we see that our mean changed from 105 to 100, so it went even from being pretty far to the right of the median to being a little bit to the left of the median. So the mean is very affected by outliers. And it makes sense because the calculation for the mean does actually take into account every single data value. Where the median may still move around a little bit when you take out an outlier, it won't move any more than it would if you had taken out another point that's on the same side. So in this case, I took out 138, 138, and 141. The median didn't move over any more than it would have if I had taken out, say, like a 102, something that was much closer to the center, but still on the right. All right, so the shape we were just looking at, let's look at it again. I think we decided bimodal, but even being bimodal, it still looks pretty close to symmetric because if we think of this bar here as being our center, we go about as far out in both the left and right directions from there and still get data values. So possibly bimodal. But still fairly symmetric. And we might even start to consider those values on the left to perhaps be outliers at this point. They didn't look like outliers in the original data set, so I'm thinking we'll just still consider them to be part of the mainstream here. So hopefully this gives you some idea of what you can do in Statkey with one quantitative variable. We can get means and medians, we can get graphs, and we can play around with our displays to find whatever it is we're looking for.